Find and classify the critical point of this function. It says critical point, so that's actually a clue as to tell you that there's only one. And so, to find the critical point, you have to take the partial derivative with respect to x and set it equal to 0, the partial derivative with y and set it equal to 0. Solve both of those at the same time. What is the partial derivative with respect to x? It's an exponential, so we're going to have that same exponential. In fact, let me be lazy. And just copy and paste it from here. Okay, good. So we have e to the x squared minus y squared plus 4y, and then we do the chain rule where we multiply that by the derivative of the exponent with respect to x. 2x. Partial with respect to y, that's exactly the same exponential, but now the chain rule will be the derivative of the exponent with respect to y. So we'll get minus 2y plus 4. And we need to set both of these equal to 0 at the same time and solve that algebraically. Now the exponential is never 0. So if the partial derivative is going to be 0, it's going to have to come from the other part that's multiplied by that, which is 2x. And so, well, that means that x is 0. Same thing again with the partial derivative with respect to y. The exponential, it's never 0. We have two things multiplied to give us 0, two terms multiplied to give us 0, and one of them is never 0. It must be the other one that has to be 0 then in that case. So that means that negative 2y plus 4 is equal to 0, or that 2y is 4, y is 2. So we have the point 0, 2, and we just have to classify it as a local min, a local max, or a saddle. It's one of these three here, and we can immediately then rule out the other answers. Okay, great. So how do we do that? Well, we have to go to the second derivatives. Second derivative with respect to x is product rule. So we'll have exactly the same thing again. Let me just cut and paste, or copy and paste. The derivative of the exponential part is exactly this guy again, and that gets multiplied by the 2x part. And so that's half of the product rule. And then the other half of the product rule will come from leaving the exponential part alone and multiplying by the derivative of the 2x part. So that's going to be multiplied by 2. That's your second derivative with respect to x. Second derivative with respect to y, double y, f sub y will be similar. F sub y is going to be that same exponential term, its derivative, and all of that's going to be multiplied by that negative 2y plus 4. And so once again, this is the derivative of the first with respect to y times the second, and then we put a plus sign, and we leave the first alone and multiply by the derivative of the second. And the derivative of minus 2y plus 4 with respect to y is minus 2. And then finally we need a mixed partial, and that's going to be f sub xy. Sorry. So take your f sub x partial and then take its derivative with respect to y. So take this f sub x partial, take its derivative with respect to y. Okay. Product rule again. Derivative of the first times the second would be this guy again, yeah. Derivative of the first with respect to y times the second. And then when it comes time for the other part, it's going to be 0. We'll have plus the first times the derivative of the second, which is 0. And so what we need to do is evaluate each of these at 0, 2. At the point 0, 2, x is 0, y is 2, we get 0 plus 2 e to the 0. No. Negative 4 plus, sorry. Negative 4 plus 8 would be 2e to the 4 for that guy. Then we have the other guy at 0, 2. What we're doing is doing this capital D function. What is that going to be? E to the 4. That'd be times 0. Plus negative 2e to the 4. And then finally, the last guy is going to be 0. And so fxx times fyy minus fxy quantity squared is negative. So it's a saddle point.